Now that we can do mole calculations in chemical equations, now we can look at mass and how that's affected. So we first are going to look at how we convert moles of reactant to grams of product. So basically what we're going to do is we're going to take moles of reactant and we're going to convert that to moles of product using the molar ratio, the mole-to-mole conversion factor. Why is that? Because if I'm wanting to know how many grams of something is, I'm first going to have to know how many moles that is. Because remember, all compounds and all elements have different grams that are associated with with 1 mole. So my molar ratio is 3 oxygens, O2, with sunlight is going to convert to 2 O3s, which is ozone. So I take moles of reactant and then convert that to moles of product. So in the first case it's O2 and I'm converting to O3, and my molar ratio is going to be 3 moles of oxygen to 2 moles of ozone. Once I get to moles of ozone, then I know that I can convert moles to mass using the formula weight, and that'll give me grams of product. So I'm first going to convert moles of reactant to moles of product, and I use that molar ratio. And so it's set up as a conversion. I can do either one of these, right? So if I'm starting with moles of O2, then I know that moles of O2 would have to be on the bottom in order to cancel that out. Then I'm going to convert the moles of product to grams of product using the molar mass. So the molar mass of O3 is 16, because that's 16 grams per mole for each oxygen times 3 gives me the formula weight, or the molar mass, of 48.0 grams per mole. And again, that's a conversion because 1 mole of O3 is the same as 48.0 grams of O3, and I can do that either way. And so I'm going to use that in order to cancel. So what I started out with was 9 moles of oxygen, and it wanted to tell me how many grams of ozone that I could make. And so remember that it was 2 O2s, right? No, 3 O2s going to 2 O3s. Too many of the same number. All right, so I've got moles of O2, so moles of O2 is going to have to go down here. So for every 2 moles of O3, there's 3 moles of O2. So then that cancels my moles of O2. And then, so now I'm at moles of O3, and I want to know how many grams of O3. So moles of O3 will go on the bottom with that conversion, so I can cancel moles of O3, and I'll be left with grams of O3. And so 9 times 2 times 48, and then all of that divided by 3. Alright, so everything on the top divided by everything on the bottom, and your answer should be 290 grams of O3, and that's because there were 2 significant figures. Okay? So if we're going to convert grams of reactant to grams of product, that's going all the way. Okay, so what you're going to have to do is you're going to have to go from grams to moles to moles to grams. Okay, so this will be your reactant and this will be your products. Alright, so the question is ethanol, whose molar mass is 46.1 grams per mole, is synthesized by reacting ethylene, C2H4, with a molar mass of 28.1 grams per mole with water. How many grams of ethanol, so that's what we're looking for, grams of ethanol, are formed from 14 grams of ethylene? Alright, so this is the ethanol, and this is the ethylene. Alright, and so I have 14 grams of this, and I want to know how many grams of that I can make. So this is just showing you how you have to basically change everything from grams of reactant to moles of reactant using the molar mass, and then the mole ratio from the balanced chemical equation gets you to moles of product, and then you use the molar mass of the product to get grams of product. So 14 grams of C2H4, so I'm going to put grams of C2H4 on the bottom. 1 mole is the same as 28.05 grams of C2H4. So now I need to get rid of moles of C2H4. So that's going to go on the bottom, and this is the molar ratio. Oop, not writing very good. Alright, from this reaction. Okay, it's 1 to 1 this time. So that gets me from moles of C2H4 to grams of, or moles of C2H6, I should say, to grams of that, because I can cancel this and then multiply everything on the top and then divide by everything on the bottom, and you should get 23 grams of C2H6O. Now I want to show you something that I've kind of come up with called somewhere over the molehill. And what this picture is showing you is this. When you are going from grams of something or atoms of something, like, and we're just going to call it A, you can't go directly from grams to grams. Okay, you cannot go under the molehill. You've got to go over the molehill. Okay, so basically, if you have grams of A, okay, grams of A, and you want to get moles of A, then you're going to use the formula weight. If you want to go backwards, moles of A back to grams of A, you're going to use formula weight. If you want to if you have atoms of A to moles of A, you use Avogadro's number. If you've got moles of A that you got either one of these two ways, and you want to get to moles of B, like you have a balanced chemical equation, then you're going to use the molar ratio between those in that balanced equation. And then once you've done that, if you want to know grams of B, you just use the formula weight. If you want atoms of B, you just use Avogadro's number. Does that make sense? So if we look back at this last problem, this C2H4 and H2O to give you C2H6O. We know so when I draw this, when I'm just like doing it to help me do the problem, I just do my molehill like this, okay? And so I put a line here. Alright, so because this is moles of whatever I started with, so in this case it's C2H4, and this is moles of C2H6O, because that's where I'm going. Alright, so I've got grams of C2H4, and I want to know grams of C2H6O. And I cannot go straight under the molehill. I've got to go over the molehill. So to get from grams to moles of C2H4, I use the formula weight of C2H4, which is 28.05 grams per mole. That'll give me moles of C2H4. Then I use the molar ratio from the balanced chemical equation, which in this case was 1 to 1. 1 mole of C2H4 to 1 mole of C2H6O, and then that gives me moles of C2H6O. And then in order to get grams of C2H6O, I use the formula weight of that, which is 46.07 grams per mole. And then I have grams. So I'm thinking like going over that molehill from grams to moles of the first one, which was C2H4. The molar ratio from the balanced chemical equation gives me the moles of the C2H6O, and then I use the formula weight of the C2H6O to give me the grams. So it's just a little way that I look at it that kind of helps me remember it. So if the molehill helps you, use it. If not, then just try to do it the book way.